In this video, I want to do a rough overview of the ControllerBody2D. It is the component that controls characters like NPCs, enemies, or summoned allies. And player controller also inherits from ControllerBody2D. So it controls all those and injects them into the physics system. Since we're using low-level physics inside Unity and not box glider or anything like that, we had to do things a little bit different, but that's okay because I set up components already for people. So let's actually start setting this guy up. So this is my guy Loki here. We're gonna just give him a controller body. So ControllerBody2D, if we open up, you'll see it inherits from physics controller. I made a video earlier today. If anybody wants to see more about the physics controller base class, they can go in there. But for anybody that's watched that video, you'll see that there's your grounded speed, your modified speed, which is basically the current physics shows like whatever your current modified speed is or any other type of physics related properties. Imagine like you're walking in water. While you're in water, you have like a slower movement speed, stuff like that. So it shows that. And volume type shows if you're in like a gravity zone or water zone. I'm going to be adding wind soon. Then you can see what your current direction is, the direction for last frame, and whether your character is like frozen and stuff like that. Also like your movement state, attack state, and everything like that. And to basically get this actually going and working, we can just add a custom SF shape component. SF shape component is a custom component I made that implements the low-level physics. So I'm not using any collider or any rigid body inside the project. There's no rigid body, there's no colliders. I wrote my own components for multi-threading and burst compiling. So you can just add any type of shape component. I'm going to just add a rectangle shape to him. I'm going to just grab him on there, and I'm going to just readjust the size a little bit. You know, I'm still working on like the size handling for like editor tools and stuff, but that's okay. For now, it works. So the SF rectangle shape, inside of it, you can choose what categories that this object is part of. So not an enemy, we're going to say friendly. So put them on a friendlies layer. You'll notice that our contacts can be like platform, player, and enemies. So the context layer is what you actually are able to interact with and the categories layer is what this object is part of. Do know you can have multiple. So I can have like a friendly, and then I can also say interactable. So now Loki is interactable, and so forth. That's a huge difference between the old physics system for 2D. So like before is based off like layers. I do not do that. I'm actually just using categories things. So you can actually make it a lot more flexible. And surface material is basically like your friction, bounciness, stuff like that. We're not going to worry about that for our character. We don't need a bouncy character. Do you know, fun fact, you can actually set the bounciness to something higher and actually set the bouncy mixing to minimum. And there's actually a way to make it where whenever another object touches this surface, it bounces up. So like imagine you have a mushroom enemy. And I'm saying this because I actually have a mushroom enemy. You can jump on its head and its head bounces you up. So stuff like that. You definitely want to make sure density is higher than 0. Don't let it be negative if you want physics to properly work. And you can choose whether it's a trigger. Even if it's not a trigger, it can still interact with trigger events. So imagine like this character is a dynamic body the body is not a trigger, but he walks into a trigger like a sign or something that you can like hit E, interact with, and read it. So you can tell if it can activate trigger events, contact events, hit events. Hit events are basically contact events that are like done between like kinematic and dynamic bodies over a certain velocity, which is actually set inside the physics settings. So for anybody that hasn't actually this, there is actually like a full-on settings for like what has to be the minimum contact event threshold. So you can actually set like what is the minimum amount of velocity and like force to actually have a contact event. Useful for like bullets and projectiles. So yeah, And basically you can just set these up, and you can also choose to set up whether the first frame he checks static contacts and so forth, and a few other things. And inside here, you have your body definition, which is where you do like dynamic, static, kinematic. And I'm going to just say, I'm going to restrict his body constraint to only rotation, so he can't like fall over on himself or anything. And transform right mode, you can do interpolate, extrapolate. At the current moment, the current transform right mode is honestly the best with my toolkit. Yeah, and you can see some other starting values. Do note these are the starting values whenever the physics system, the low-level physics system actually creates the physics shape. So these are not generally updated as the like game actually runs. So just heads up. But that's specifically bond definition. Then you can have scale size, and basically like if you like scale up the transform, does the shape scale with it? And you can obviously have the size of the like the shape and everything. And if you really want, you can have a corner radius. So yeah, there you go. If you want to have like a rounded radius, for anybody that's like played those platforming games where you have like a edge and you're like walking off it and you just kind of hang on there, you can actually set a corner radius to kind of help work with that a little bit, and so forth. Yeah. So you just set that up, assign it as the shape component. And if I actually hit play here, if I remember right, I hit this to dynamic. Loki will fall. There you go. So Loki actually is affected by gravity, and he's actually interacting with the world, but there is not a single box collider or anything on it. Yeah. Or there's also no ray casting. And if we actually go to ControllerBody2D, you'll notice that inside of it, there's a thing called collision info. The SF shape components actually direct the collision info into this value. So if we actually go here, you'll see gliding below and is grounded, was grounded last frame, so forth. You can even have like, is he climbing a surface? Is he colliding left to right? So if I actually come, you'll see that he's now colliding left because I'm touching him on the left side, so forth. And you can read all these values in code too, so you can actually basically interact with anything. For example, if we actually go into here, the zombie actually, like some of the NPCs and enemies, whenever they glide left, they actually turn around. So that's one of the things you can actually use this for. And you also have like some movement booleans and stuff like that. That's literally all you got to do to set up a character that actually interacts with the low-level physics system. Going into the code, let's actually go into the code real quick. So, like I said, I made a video for Physics Controller 2D this morning and already uploaded it. So if you want to know about the base class, you can go look at it. But basically, controller body has a character state, and it's just a serializable class that keeps track of the current movement state. And movement state can be any, like crouching, walking, whether you're falling, gliding, stuff like that. And I should actually, I'll have to remember to change that to UN because I have a reason for that. But anyways, it also keeps track of like when the movement state changes, so you can actually register on movement state change. So if the character goes from like is falling to is grounded or something like that, you can actually respond to it. And also keep track of the current attack state. So maybe you're like starting attack and finishing attack and stuff like that, and so forth. Character status is like alive, dead, respawning, or like knocked out. And there's also a reason why we have the character status inside this is there's actually a on-death handler system. So basically, like when a character dies, you can actually freeze the freeze the movement of the object. So like imagine the blood zombie. When I kill the blood zombie, instead of like he freezes and he like goes into his death animation and spot. So you can do stuff like that. Same thing with status effect. You can do like different status effects. And the reason why status effects and stuff is like actually part of the ControllerBody2D. Imagine you have like status effects like slowed that actually like reduces the character's movement and stuff like that. And there's obviously like a restore movement state. Yeah, basically that's what the movement is for. Oops, sorry, go back to there. And SF shape component, like I said, this is my custom physics system. That this is basically a set of tools I created to work inside the Unity editor with physics shapes and physics bodies a lot easier. This is basically starting from 6.3 and up, you can start using this. So that's why this is also why the Metroidvania package requires 6.3 or newer to work. I'm only going to support those versions because I am using the physics shape and physics body stuff. But yeah, you'll notice that a lot of this is actually using native lists, burst compile, and also low-level memory management in some areas as well. You guys probably don't want me to go that deep into how to do this. I'll make a dedicated video for that. But just wanted to show off that's what the SF shape component is. Then you have your booleans for is running, swimming, jumping, falling, so forth. And you also have a stuff specific for is climbing, mainly because like two-way or four-way climbing. So imagine like if you could turn around and so forth. Like if you're climbing up a ladder, you can't turn your character, like move your character like left and right. You can only go up and down. But imagine like in Mario games where there's like great, you can climb like all directions in, stuff like that. So that's why that's there. And the body collision info is actually be able to pass into anything. It literally keeps track of when you started colliding something, if you're currently colliding something, what you were colliding with last frame and so forth. And this is actually what calls the callbacks or like on ground and handler and so forth. So if you ever need to do something specifically when you are grounded, you can have any class just register a listener to the on ground and handler. Same thing with the is colliding left and right. If we actually go through here, there's actually an area where we can actually check on collision actions. And if we weren't colliding last frame, but we are now colliding this frame in any direction, you can say it actually calls the on collided in whatever that direction is handler. So this is how I actually am changing the direction of zombies whenever they hit a wall to the left or to the right. So anytime you need to check for a character hitting ceiling walls, stuff like that, you can actually do this. Yeah. And the body collision info, that's actually inside of the controller body. Class, it inherits from collision info base. It basically allows you to like keep track of like what object you're standing on. Useful if you have a moving platform and you want the character to move with it. What object is being controlled with the collision, whether the object can actually do collision, and you can set like a minimum threshold for like collision contact to prevent like ghost collisions, stuff like that. And basically, the base class also has the handlers as well. Yeah. Then you have character renderer. I'll make a dedicated video to that. But we have the move, which is inherited from the base class for Physics Controller 2D. Here you can actually take whatever value was calculated, like the velocity, and actually apply it to the SF shape component. And that's basically how a character moves, and you can actually see like where the external and calculated velocity are used. That's also where I'll be like doing the final slope checks. I need to update the slope method. And if you've seen the previous video, I mentioned that the base class for physics controller, the horizontal and vertical methods are abstract, so you can customize them. So you can have like grounded enemies, flying enemies, and you can change how you're calculating the horizontal and vertical. This is basically also where like we do like stop the character from like continuously trying to like run into a wall, stuff like that if he's colliding left or right. And also where we check for like is grounded and like is climbing to make sure that while we're climbing or not or currently grounded to not just continuously add gravity to the velocity. And calculate movement state basically allows us to declare the current movement state, and the current movement state is actually plugged into the character renderer, And the character renderer actually, let's see, I believe it should be under, is climbing, yeah. So the current movement state is actually injected into character renderer 2D. And I can actually use that, for example, to automate animations. That way I don't have to manually set up so many like animation states. For example, if I go to the player, you'll notice that I go to player controller and I go to character state. The current movement state is idle right here. And if I actually open up the animator, you'll notice, oh look, the animation state's idle. If I actually start changing my character movement state, so if we go from idle movement state to walking, you'll notice that the animation state updates. So I have it where the movement state actually syncs up animators to help simplify creating animator controllers for characters. That's what that's for. And go all the way back down. And then just like you would expect, basically just setting up the new collision info on awake, making sure that I actually have a some type of FF shape. If one is not attached to a controller body, it automatically adds a capsule to prevent any errors. And you can basically see I go in fix update. We just check for collisions. If you ever need to check for collisions, you can just call the check collisions on the body collision info, and that's where it'll check for like ground collisions, ceiling collisions, and so forth. And basically, yeah. So that's pretty much it. For the most part, there is like the update physicals property, which is what I mentioned earlier, where like if you enter water and then exit it, you can like update like your character physics in it and so forth. I still got to implement a couple things in there, and there is going to be a resize physics shape method. Example, when you crouch, like if you crouch, you might have your like a hitbox like shrink a little bit, stuff like that. So that's going to be adding support to stuff like that. So like if I crouch right now, you notice my physics shape is not updating. That's the last thing I gotta like implement for like crouching. And also you can also resize your physics shape box when you're like climbing. So if you're climbing a ladder, you might make it where your character has like a smaller width for your hitbox, stuff like that. By the time this video is out, I'll probably have this implemented and push. I'm actually going to be pushing it for the Alpha 9 instead of Alpha 10. But that's like a kind of an overview of the ControllerBody2D. For the player body that's actually controlling the character that players are actually moving, there's just a, let's actually go, yeah, player controller 2D. No joke, all the player controller 2D is, it just inherits from controller body here. And all it does is it calls the base wake thing, and it just adds a on-game control state change setup. And I can actually get rid of this. I no longer need that with database registering. Basically just does the same thing as the base controller body 2D. But I also make sure like whenever like you're starting the game, so you're actually like hitting continue or new game and loading into game, you aren't like instantly like doing certain physics stuff until like the game is ready, stuff like that. And yeah, that's pretty much it. Like the player controller body is less than 60 lines of code because it inherits from the script that enemies and NPCs use. So I can update interactions for one character, and all characters can be updated. Do note, I want to actually mention this. If I go to calculate movement state, real quick, actually, let's go to controller body. Let's actually go to this controller. At the current moment, I have this thing, it's movement properties. I'm going to be naming it to grounded physics properties. And the reason why, flying enemies don't need a ground speed and stuff like that. So the plan is I'm going to just rename movement properties to grounded physics properties. And I created an interface called iPhysics controller properties. And basically, the controller body 2D, you can actually set it up where it's either a grounded or a flying type of body, and it'll actually update the values that you actually see inside of the editor and actually use inside your character's controller body. That way, like flying enemies don't have like a lot of flying enemies do not need any of that. They only need like one thing for like I'd say like basically like two things. Like maybe they have like a fly speed and then like a fly dash speed or something like that, if they want to have like a dashing speed. But yeah, just heads up on that. So that will probably be done in Alpha 10. I'm not doing that in Alpha 9. That is a lot of changes I got to work on. But just heads up, that is something I'm planning to do. And that's basically it. That's literally how the player and NPC enemies all use the exact same type of controller interactions.